Today we'll study gross thrust. Gross thrust is also known as static thrust. Gross thrust is the total thrust produced by the engine at the exhaust nozzle without considering the momentum of the incoming air. Gross thrust formula. Gross thrust is equals to mass flow rate of exhaust gases multiplied by velocity of the exhaust gases plus pressure at the nozzle exit minus ambient atmospheric pressure into area of the nozzle exit. For example, the aircraft is stationary or in static condition with engine on, we can calculate the gross thrust. Second, net thrust. Net thrust is the actual force available to propel the aircraft forward. To find the net thrust, we must subtract the ram drag. Ram drag, the force required to slow down the incoming air to the engine's intake speed from the gross thrust. For example, in stationary engine, when the aircraft is at a standstill, the velocity is equals to 0. Then the net thrust is equals to gross thrust. But now the above video shows that the aircraft is in flight condition, so that as the airspeed increase, ram drag increase. That is why net thrust is generally reduced when increasing forward airspeed. Third, choke nozzle. A nozzle becomes choked when the velocity of the exhaust gas reaches the speed of sound, means Mach 1, at the narrowest part of the nozzle, means the throat or exit. Pressure ratio. Choking occurs when the ratio of internal pressure to ambient pressure reaches a critical value, approximately 1.85:1 for typically exhaust gases. Three phases for nozzle state. First, static takeoff phase. Nozzle state is slightly choked. Second, high speed cruising state. The nozzle state is choked. In third, the idle taxiing phase, the nozzle state is not choked. Example, once the exhaust reaches Mach 1 at the nozzle narrowest point, the nozzle is choked. Even if the pilot dumps more fuel, the gas cannot move faster through that opening.